Alright, so let's take another look at an example just like the introduction video. In this example, we're just going to take what was talked about previously, which is what we call slope-intercept form, and we're going to try to graph another line. Now once again, here's the idea. When you have an equation in slope-intercept form, and you've got y all by itself on one side and all the information on the other, these numbers, m, which is always the number next to x, and then b, the number off by itself, actually give us information about being able to take the data and graph it. And it actually saves us some time, because if we didn't have that information, what we'd have to do is we'd have to do a table, we'd have to pick some numbers for x, we'd have to plug them in one by one, get some numbers for y, and then graph it point by point. And it takes a long time. There's nothing wrong with it, and it's a way to do the mathematics of it, but why do that when we've got a shortcut, which is what's, once again, slope-intercept form. So let's take a look at this example right here. Now, this equation is in slope-intercept form, and I can tell that because y is all by itself on one side of the equal sign, and all that other information's over here. And what I end up getting is two different numbers. One number, the number next to x, is what we call the slope. So in this case, the slope, or m, is positive 2. And then the number off by itself is this minus 5 or negative 5. Now be sure to include it. When it's subtraction, think of this like a negative 5. And so our y-intercept is negative 5. And the reason why, like I said, it's a shortcut is because this is all we need to graph it. I don't have to do a table. I don't have to have a bunch of data to graph it. I can just use this information. Now, this is called the y-intercept once again because it's where our line is going to cross the y-axis. So even though I don't know which direction the line is going or what angle it's going to be at, I do know that my y-intercept is negative 5. So I do know that that line is going to intercept the y-axis at this point right here. Now I need the slope. Now in the previous lesson we did talk about slope, but we know that slope is always referred to as rise over run. And we need two different numbers. Now this doesn't have it, but we've got a simple remedy for that situation. Instead of just 2, we're just going to change it to a fraction. And the easiest way to do that typically is just to place it over 1, because 2 divided by 1 is still 2. So that's telling me if my line crosses here, then the direction I want to go is to rise positive 2, run positive 1, and my line will go that direction. And I'm going to do that a few more times so I can see it clearly. Rise 2, run 1. Rise 2, run 1, rise 2, run 1, so on and so forth. And so by doing it this way, I get all my information graphed on the graph, and I didn't have to go through all the extras of making a table. So now, all I have to do is join the information. We'll just borrow the ruler here and draw a line connecting the points. Okay, and so that's, oops, it's off a little bit, but you get the idea. So this is how we use slope-intercept form as a shortcut from going straight from the equation to the graph and skipping the table.